Okay? Reciprocal identities, quotient identities, Pythagorean identity. Look at those names. All right. So we'll begin the class. Ready, everyone?
Yes, ma'am.
I think we stopped at question 4.
Yes, ma'am.
Okay.
Yes.
Now, I skipped question 5 for the time being. We'll go to question 6. Okay. Now, let's start with question 6. Question 6 says root of 1 plus sine A upon 1 minus sine A equal to sec A plus tan A. Now, let's start with the LHS. Okay. Now, how do we get into this? We have to bring sec A plus tan A into the picture. Now, let us have a look at the RHS. Now, what is sec A? 1 by cos A. And what is tan A? Sin A upon cos A. These are two fractions with the same denominator. So, can I write it like this? Yes or no?
Yes, ma'am.
Yeah. So, this is what I should achieve here. Even if I get this from this, my job is done. Remember yesterday we said we can simplify the LHS separately, we can simplify the RHS separately, and then we can get into it. We can do this that way also. But from here, how do I come to this? How do I bring cos A here? Anybody? Nobody? Here I have 1 plus sin A in the numerator, and in the denominator I have cos A. Whereas in my LHS, I have this. Already 1 plus sin A is present. Denominator should change to cos A. Anyway, you can get that.
And can we do square?
How can we square? Only if I have an equation 5x equal to 25. Then I can square on both the sides. But a single expression cannot be squared on its own. The value will change.
Yeah. Yes.
Now, look inside the square root. What do you have? Isn't it a
It's
fraction?
a conjugate.
Yes. It's a fraction that is available inside the square root, correct? Now, I can multiply the numerator and the denominator by the same number, and the value of my fraction will not change. So here, I think Mahalakshmi said that. Who
Yes.
said? Yeah. So we are going to multiply the numerator and the denominator by the conjugate of the denominator. Okay. Denominator was 1 minus sin A. I am multiplying by 1 plus sin A and 1 plus sin A. Both the numerator and the denominators are getting multiplied. So the value does not change. Now look inside my square root. I have two fractions that are multiplied. So I'm going to multiply the numerators together. I'm going to multiply the denominators together. Now, have a look at the numerators. 1 plus sin A into 1 plus sin A can be written as 1 plus sin A the whole square. And what is the denominator similar to?
A square minus B square.
Yes, it is of the form A plus B into A minus B. So I can write it as A square minus B square. Okay. Now, so what do I have? I have 1 plus sin A the whole square upon 1 minus sin square A can be written as?
Cos square.
Yes, I can write it as cos square. Now they are all inside the root. So when I take the square root, what will I get? 1 plus sin A upon cos, correct? When the square root goes off. Now can I say LHS is equal to RHS? You all are sleeping?
Yes, ma'am.
Yes.
No, ma'am.
Okay. So is it clear to everyone?
Yes, ma'am.
Okay. Write it down step by step. When you finish, tell me.
I'm finished.
Okay. Can we go to the next question?
Yes.
No, ma'am. Just a minute, ma'am.
Sure, sure. Take some.
Done, ma'am.
Okay. Now, let's have a look at the next question. Sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta. Think how we can start with this question.
We can take sine common and cos common.
Yes, we can take sine common in the numerator and cos common in the denominator. So then what will we get?
1 minus 2 sine square theta by
Yeah, 1 minus 2 sine square theta. And at the bottom you will get
2 cos square theta minus 1.
yes, 2 cos square theta minus 1. Oh, so let's start this. Now, if you look at the LHS is sine theta minus 2 sine cube theta. Now, let's take sine theta common in the numerator. So you will get 1 minus 2 sine square theta. And here you're taking cos theta common. So you will get 2 cos square theta minus 1. From here, what do we do? See, part of our answer is already there. We want tan theta, right? What is tan theta? Sin theta by cos theta, which we have already got here. So in short, this bracket and this bracket should somehow get cancelled, right?
Ma'am, we can write 1 minus cos square theta at the place of sin square theta.
Yes. Yeah. So what I'm trying to say is these two brackets have to be cancelled. Now, if these two brackets have to get cancelled, they should become the same. But if you look at the numerator, it has sine and the denominator has cos. You have to somehow make it the same. So as Jatin said, we are going to replace the cos square theta by sine square theta or vice versa. Using the reciprocal identity, using the Pythagorean identity, sine square theta plus cos square theta is equal to 1. So instead of this cos square theta, if I push this here, I can write 1 minus sine square theta. This I will place instead of this. Let's see what happens. So I have here sine theta upon cos theta as it is. I'm not changing the bracket at the top. I can change that also. It's up to you. Now, instead of cos square theta, I am writing 1 minus sine square theta. Okay. Now, let's slowly change. So, what will I get here? 1 minus 2 sine square theta. Let's come to the denominator. Open the bracket. 2 into 1 is 2. 2 into sine square theta is minus 2 sine square theta minus 1. Then sine theta upon cos theta into numerator is 1 minus 2 sine square theta. Look at the denominator. 2 minus 1 is 1 minus 2 sine square theta. Now what happened to this numerator and the denominator? Aren't they the same? So we can cancel them off and we will be left only with sine theta upon cos theta, which is nothing but tan theta. And that's what our RHS is. Is that clear?
Yes.
Write down. Don't copy as it is. Try to put down what comes to your mind and just have a look once in a while on the screen. Writing. Finished? Over?
Yes, ma'am.
Let's go to the next question. Have a look at the next question. Look at the LHS. Sin A plus cosec A the whole square plus cos A plus sec A the whole square. And the RHS is 7 plus tan square A plus cot square A. Okay. Now, we have to concentrate on the LHS. Let's concentrate. If you look at the LHS, what comes to your mind?
A plus B the whole square.
Yes, there are two brackets for which you have to square, and you're going to use the identity A plus B the whole square. So let's start with it. Sin A plus cosec A okay. Now let's use A plus B the whole square. So I will write sin square A plus cosec square A plus 2AB. So 2 sin A cosec A. Now use A plus B here also. So you will get cos square A plus sec square A plus 2 cos A sec A. Okay. Now what to do?
Sin square A plus cos square A is 1.
Yes, you can use the identity sin square A plus cos square A as 1. Then,
Ma'am, sin A cosec A will be 1 and cos A sec A will be 1.
yes, let's write the remaining cosec square A plus, look at this sin A. I can write cosec A as 1 by sin A. This cos square is already gone because we have added with this and it has come here. Next, I have sec square A. Now, again, this sec A can be written as 1 by cos A. So what will happen? Sin A cancel, cos A cancel. So you have 1 plus cosec square A plus 2 into 1, 2 plus sec square A plus 2 into 1 as 2. Okay? Now what?
Mom, we can use the identity cosec square A is 1 plus cot square A and sec
Yeah.
square A is
Yes. Now before that, I'm going to add these numbers. How much? I'll get 5. But what is the number that I need in the RHS? 7. That means somehow I have to bring 2 here. Correct? Now, I want tan square and cot square in the RHS. I have sec and cosec. So can I use any identity that will bring tan and cot into the picture?
Cot, cot square A plus 1 is equal to cosec
Yes.
square A.
1 plus tan square A is sec square A and 1 plus cot square A is this. Can we use that? So instead of cosec square A, I will write 1 plus cot square A, and instead of sec square A, I will write 1 plus tan square. Now add all the numbers. 5 plus 1, 6, 6 plus 1, 7, plus the remaining terms. Have we got the RHS? Yes or no?
Yes.
Anybody who has not followed may ask. You don't have to just keep quiet and watch. No doubt?
No, ma'am.
Okay.
No,
So
ma'am.
write down. And wherever you use identity, do write it in the bracket. Here we have used sin square A plus cos square A equal to 1. Ayush is following? Not there, Ayush? Let me know when you finish writing. Over? Ishita, are you following?
Yes, ma'am.
Oh. Can we go to the next one or are you still writing?
Ma'am, done.
Okay. So we'll go to the next question. Let us start this question. And they've given us a hint also. Simplify the LHS separately and simplify the RHS separately. Let us start with the LHS. Come on. What does the LHS say? Cosec A minus sin A into sec A minus cos A. Now, how can I simplify? How can I write cosec A as
1 by
reciprocal? Yes. Cosec A can be written as 1 by sin A. Same way, how can I write sec A as?
1 by cos A.
Yes. 1 by cos A. Now, what did I get in these two brackets? I got two fractions which are subtracted. Are their denominators the same?
No.
No. So I have to cross multiply and make the denominators the same. Let's do one bracket at a time. 1 into 1, 1. Sin A into sin A, sin square A. And the denominator is sin A into 1. Next bracket, again, cross multiply. 1 into 1, 1. Cos A into cos A, cos square A. And the denominator is 1 into cos A. Alright? Now what to do?
1 minus sin square A is cos square A.
Yes. Because I know the identity sin square A plus cos square A is equal to 1, I can write sin square A is equal to 1 minus cos square A and cos square A can be written as 1 minus sin square A. I can make use of that. So instead of this numerator, I will write cos square A. Denominator remains the same. And instead of this numerator, I will write sin square A upon cos A. Okay. Now, this is like multiplying two fractions. When I multiply two fractions, I can write both the numerators together. Sin square A into cos square A. Both the denominators together. Sin A upon cos A. Now, what can I do? Nothing. How many sin A's in the numerator?
Ma'am, I thought it would get cut. Like,
Yes, yes. You can still cut. You could have cut here itself, but you can still cut. There are two sin A's, no? Sin square A's in the numerator. So one of them will get cancelled and only one sin A will remain. Same way, the cos A also. There are two cos A's. So one cos A will get cancelled. Here itself you can cancel. You can cancel one of them. Both are okay. You can either cancel here or here itself. Okay. So what remains? Only sin A, cos A. Now once when I read sin A, cos A, I don't have much to do. So I now go to the RHS. Taking the hint from the question, I go to
Ma'am,
the RHS. Yes.
ma'am, I didn't understand how did we obtain cos square A into sin square A divided by sin A and cos A.
Okay. You understood why I wrote this as cos square A?
Yes, ma'am.
Yeah. Now, instead of 1 minus sin square A, I wrote cos square A upon sin A into sin square A upon cos A. Okay.
Okay, ma'am.
Now, you can either cancel here itself or because you're multiplying two fractions, you will multiply both the numerators together. You will multiply both the denominators together. Is that correct? Oh, did you understand?
Yes, ma'am.
Okay. Now coming to the RHS. How can I write the RHS? What is tan A?
Sin by cos.
Yes. Sin A upon cos A. And what is cot A?
Cos A by
Cos
sin.
A, yes, upon sin A. Now look at the expression now. I have a numerator 1 and at the denominator I have two fractions that are to be added. But do these fractions have the same denominator?
no, we'll
No.
cross multiply.
Yes, we have to cross multiply. So I'll have sin A into sin A as sin square A, cos A into cos A as cos square A, upon the denominator as sin A into cos A. Now, what will this sin square A plus cos square A become? 1. When I use the identity, sin square A plus cos square A will become 1. Now, what do I have? 1 is the numerator and at the bottom I have a fraction. So, the bottom fraction always gets reversed, correct? So, what do I get? I get only sin A cos A. Now, are the LHS and the RHS equal?
Yeah.
Got it? Any doubt?
No, ma'am.
You all are so quiet. Josh, are you following? No? Note down and tell me when you finish. Lloyd, are you understanding?
Yes, ma'am.
Okay. Mahesh? Mahesh has slept? Okay. Let me know when you finish writing.
Done, ma'am.
Okay. We'll scroll to the 10th question. Come on. Now you all have to help me with this question. Let's try it together. If you see, there are three expressions that are to be proved equal. Okay. Let's start with the first one. Now, in this case, I can't write only LHS and RHS, right? There are three expressions. Let's start with the first one. What's the first one? 1 plus tan square A upon 1 plus cot square A. How will I simplify this? Use the identity. What is 1 plus tan square A?
Square A.
Yes,
Sec square.
yes. And what is 1 plus cot square A?
Cosec square A.
Cosec square A. Now, how can I write sec square A as sec reciprocal of?
Cos.
Yeah. So can I write the numerator as 1 by cos square A and the denominator as 1 by sine square A? Because cosec is the reciprocal of sine and cos is the reciprocal of sec. So I substituted them by the reciprocal. Now I have one fraction upon the other. So I can write multiplication and I can reverse the denominator. So now what will I get? 1 into sine square A is sine square A. Cos square A into 1 is cos square A. Sine upon cos is tan. So tan square A. Did I get this?
Yes, ma'am. Yes, ma'am.
Yeah. Now start with the other expression. 1 minus tan A upon 1 minus cot A the whole square. Okay? Start.
Ma'am, for both expressions, we have to get tan square A, right?
Yes. Separately square the numerator and the denominator. Which identity will you use to square the numerator?
A minus B the whole square.
Yes. A minus
Ma'am,
B.
otherwise we can write cot as 1 by tan, that's all.
Yes, you can. Okay. So what will I get here? I'll get 1 plus tan square A minus 2 tan A using A minus B the whole square. And the denominator, I'm using A minus B the whole square. So I'll get this. Now, can I use any identity? Can I use any identity?
In the denominator, it will become
sec square a.
Yes, 1 plus tan square A is sec square A minus 2 tan A upon what is 1 plus cot square A.
cosec square.
Cosec square a.
Yes. Then what to do? I'm waiting for you all to tell me what to do. There's no single method in trigonometry. You can use any method to finally bring the LHS and the RHS together. No? Can I write my sec as 1 by cos and this as 2 sin A upon cos A?
Yes, ma'am.
I'll write on the next page. So I can write this as, and this as 2 sin A upon cos A. Now, look at the numerator. There are two fractions which have to be subtracted. Are their denominators the same?
No, ma'am.
No. So I just have to make their denominators the same. So cos A minus 2 sin A, or I can just keep this as 1. Because if I multiply this by cos A, the denominator will become the same. So I can just write 1 minus 2 sin A cos A upon cos square A. Same thing I can do with this also. I can just multiply this by sin A and sin A to make the denominators equal. So I will have 1 minus 2 cos A sin A upon sin square A. Now what do I get? I get a fraction at the top, I get a fraction at the bottom. So what can I do with the bottom fraction? What do I do?
Multiply the reciprocal.
Yeah. So what happens to this expression?
1 minus sin A cos A gets cancelled.
Cancelled, and only sin square A upon cos square A remains, which is the same as, got it? Think, write. If you don't follow, ask. Don't blindly copy down. When you write each step, think what you're writing. And if you don't understand the logic behind why you're writing it, ask.
Ma'am,
Yes.
ma'am, have you got that 1 minus 2 sin A cos A by cos square A?
Where? Which step?
Ma'am, third last, that one.
This one?
Yes, ma'am. Have you got that one?
This one? Okay. See, here I have a numerator. Look at my numerator. My numerator is this. Correct? This is my numerator.
Yes,
I
ma'am.
have two fractions. One fraction, the denominator is cos square A. Other fraction, denominator is cos A. Now, if I have to subtract, I have to make the denominators equal. Correct? Now, the only difference between the denominators is this one has 2 cos A. So it is cos square A. यहाँ पे एक ही cos A है. So what did I do? I gave an extra cos A to both the numerator and the denominator. Okay. So now this fraction was same. This became 2 sin A cos A upon cos square A. Now the denominators are the same.
Yes, ma'am.
Okay. It is like if I have 1 by 2, sorry, if I have two fractions, 1 by 4 minus 3 by 2, I have to subtract them, but the denominators are different. So I give this into 2 into 2. So I will get 1 by 4 minus 6 by 4. Now I can subtract, correct? The same thing I did here. Followed?
Yes, ma'am.
Okay. As I told you, it's all about your basics on fractions. Okay. The chapter largely depends upon how good you are in fractions, which we've learned somewhere way back in class 6 and 7. So brush them up. Now that you're older, it would be easier for you to understand. Over?
Yes, ma'am.
Ma'am, 1 minute.
No problem. Take your time. Not 1 minute. Take 10 minutes. No problem. But keep telling me. Over?
Yes, ma'am.
Everyone?
Yes, ma'am. Yes, ma'am.
Okay. Okay. We skipped a question. Let's go back to that question. I'll just add a page here. It's a little long. Okay. Now let's come back to this question. Cos A minus sin A plus 1 upon cos A plus sin A minus 1 equal to cosec A plus cot A using the identity cosec square A equal to 1 plus cot square A. Okay. Now, we all know that if you have to use the identity, somewhere we need the square form, which is not there in the LHS. So somewhere we have to bring a cosec square A, we have to bring a cot square A. Right? Only then we can use the identity that they have mentioned. They've given us a hint. And to use that, we have to bring a square form. So how will we bring a square form? Let's think.
I'm squaring both sides.
We cannot square both sides because we are actually proving that they are equal. Right?
Okay.
Yeah. If we already know that they are equal, we can square. But here, the question says prove that these two are equal. So we cannot square on both the sides. Yes, but keep thinking like this.
Ma'am, we can divide throughout by sin.
Yeah, that's a good thing to do. See, from cos, we are going to cosec. From cos, we are going to cot. The only difference between these two, what is the RHS? Let's have a look at the RHS. RHS is cosec A plus cot A, which we have to bring here. But we have only cos and sine. But I know cosec is 1 by sine A and cot is cos A by sine A. That means I need the denominator as sine A to get these two into the picture. Correct? So what he said is correct. We can divide this LHS throughout by sine A, because whatever we want to bring in the RHS has a denominator as sine A. So when we start with LHS, cos A minus sine A plus 1 upon cos A plus sine A minus 1. So if I have to bring cosec and cot, I should have some denominator. And what is that denominator? Denominator should be sine. So what I do is, through the entire numerator, I put a denominator sine. I divide the whole numerator by sine. So I have to do the same with the denominator also. Otherwise, the value will change. Why am I doing this? Because my RHS contains cosec and cot. And cosec and cot have denominators as sine. So I chose to divide my LHS also by sine. Okay. Now, can I bring cot A? Can I write this as cot A? So what will this become?
One.
1. And what will this become?
Cosec A.
Cosec A. Now, what will this become? Cot A. This and this cosec. Is this much clear to everyone?
Yes.
Okay. Now, can I write it like this? Just have a look and tell me, have I changed the meaning? Have I?
No.
No.
No. Yeah. I wrote this in a particular way because I wanted to get A minus B at the top and A plus B at the bottom. That is the reason why I wrote like this. Now what should I do? Tell. This is enough of an hint.
Ma'am, we can multiply and divide by A minus B.
Yes, we can multiply and divide by the conjugate of the denominator. So conjugate of the denominator will be cot A minus 1 minus cosec A upon cot A minus 1 minus cosec. Got it? Now, so what will the numerator become? Is the
A
numerator the
minus
same?
B the whole square.
Yes, very good. Who said that?
Sharvari.
Good. So, Sharvari, you only tell me what will the denominator be?
A plus B into A minus B. A square
Yeah,
minus B.
yes. So, cot square A minus 1 minus cosec A the whole square. Correct?
Yes.
Okay. Now, write this much down step by step in your books. When you write, you should think and write. Then we'll proceed further. This much you note down. And you can even try going further on your own. Think and do. Why did we divide by sine A? Because my LHS had only cos A sine A, whereas my RHS had cosec and cot. Cosec and cot both have sine A in their denominators. So I had to bring a sin A in the denominator of my LHS also. That's the reason why I brought sin A. And the reason here will be dividing the numerator and the denominator by sin A. Done? Those who have done, after the last step, use a minus b the whole square in the numerator. Open the bracket. Tell me what you get. Have you written this much? Can we go further?
Yes.
Okay. So a minus b the whole square. So I can write this as a square plus b square minus 2ab. Right? What did I do? I only wrote a minus b the whole square, where my cot A is a and this entire expression is my b. So I just wrote a square plus b square minus 2ab. Okay? Same way, do it at the new denominator also. Cot square A as it is, and this will be a minus b the whole square now. So 1 plus cosec square A minus 2 cosec A. Okay? Now let's look at the numerator. Cot square A as it is. This bracket we have to open. So it will be 1 minus cosec square A minus 2 cosec A. A minus B the whole square formula. Now open this bracket. So 2 minus 2 cot A plus 2 cot A cosec A. Cot A cosec A.
Ma'am, it will be 1 plus cos x square A
Where?
in the numerator here. In the
Acha,
end.
yeah. Next step we'll replace, no? That's what you're saying, right?
No, ma'am, you have like opened it wrongly. A minus b square will be a square plus b square, and you have written a square minus b square.
Okay, I'll write it again. Anyways, there was no space. Cot square A, just point out if I'm wrong. 1 plus cosec square A minus 2 cosec A minus 2 cot A plus 2 cot A cosec A. Is there an error?
No, ma'am, right now.
Now, let me open the bracket for the denominator. Now, let's see if there are any cancellations.
Ma'am, we can put the first
Cot square
cos square
A.
A minus 1 minus cosec square A plus 2 cos square sec A.
Yeah. Can I write 1 plus cot square A as cosec square A?
Yes, ma'am.
Yeah. So I will get 2 cosec square A. because this is 1 cosec and this is 1 cosec. So I'll get 2 cosec square A, correct?
Yes.
Yes, ma'am.
And the remaining I'm writing as it is. Is there anything that I can cancel? I don't think so. So I write it as it is. Now come to the denominator. Is there anything that I can do in the denominator?
Ma'am, 1 minus cosec square A will be cot square A.
Yes. 1 minus.
Cosec square A.
Okay. Right, like. Instead of that, shall I write cot square A as 1 plus cosec square A? Sorry. Cosec square A as 1 plus cot square A. That
Yes.
will be easier for everyone to understand. So instead of this cosec, I am writing 1 plus cot square. Now you understood why I left this question in the beginning, right? Now, let's take 2 common at the top. I don't know if it helps, but we are just writing. Let's see. Instead of writing 2 so many times. Now,
Ma'am, we
what
can cut
happens?
the cot A and minus cot A and cot A.
Okay. Now look at the denominator. When I open the bracket, cot square A minus cot square A will get cancelled. Minus 1 will become minus 2. Right? So it will be minus 2 plus 2 cosec A. Can I take 2 common here also? So what will I get?
2 will be cancelled.
Yes. So I can cancel the 2. So what do I get? Cosec square A minus cot A. Okay. Now look at my numerator. I am taking cosec A common. So I will get cosec A minus 1. And here if I take cot A common, what will I get? Cosec A minus 1
Cosec minus 1.
upon cosec A at the bottom. So now again in the numerator, I can take cosec A minus 1 and cosec A cot A plus cot A upon cosec A. Right? So cosec A,
Cosec
cosec A
A
gets
minus 1,
cancelled.
cosec A minus 1 cancel.
Yes. Got it? Is that the RHA? Yes or no? Not clear?
Yes.
Okay, write it down. We'll end here. The exercise is over. We'll meet
Ma'am, can
tomorrow.
you explain the fourth last step again? No, the fifth last.
Fifth last. Tell me what step it is
I
from the
mean,
top.
second step.
Okay. See, what did I do? I use the identity 1 plus cot square A is cosec square A. Okay. So this entire So this entire expression 1 plus cot square A became cosec square A. That cosec square A plus this cosec square A became 2 cosec. Is that clear?
Ma'am, the denominator I am confused in.
In the denominator, instead of this cosec square A, I wrote 1 plus cot square. So when I open the bracket, this became minus 1 minus 1. Okay. And this
Okay.
became cot square A minus cot square A, which got cancelled. Follow?
Yes.
Ma'am, ma'am, in fourth last step, have you got in denominator
No,
cosec
don't
a
say fourth
minus
last
1
step. Say from the top which step?
from the top third step?
Third step. How did I cut the denominator?
No, have you got the denominator?
See, open the bracket for this. Cot square A minus 1 minus 1 minus cot square A plus 2 cosec A. Correct? So cot square A cancel. Minus 1 minus 2 becomes minus 2 plus 2 cosec A. So if I take 2 common, I will get cosec A minus 1. Clear?
Yes, ma'am.
Okay. So if you have written, shall we end the class?
Yes, ma'am.
Okay then.
Ma'am,
Yes.
Thank you, ma'am.
I had a doubt and one question.
Which question?
It's different. It's not in the exercise.
Yeah. Who's that?
Ma'am, Prajakta.
Yeah, Prajakta. You just stay back. The others can leave.
Okay, ma'am.
Okay, and I'll let or join after 5 minutes. Okay. As I'll just drink some water and I'll join after 5 minutes. Those who want to clear that doubt, stay back. The others can leave. Okay.